This week, we will be looking at exponential functions, which show up in both sections 4.1 and 4.2. 4.2 is going to look at exponential functions using the natural number as a base. I'll talk about that briefly here, but I'm going to leave that mostly for you to read about later. So what is an exponential function? Basically, it is a function where the variable appears in the exponent. So something like f of x equals 2 to the x. In the past, we would have seen f of x equals x squared. The variable would have been down here as our base and a constant up top. But now we have a variable up top. We could also, this is what we call a basic exponential function because it has the form f of x equals b to the x. However, we could also see a transformed one, and we will later on. Something like g of x equals 5 to the 3x minus 1. That would still be an exponential function, it's just been transformed. Instead of just being of this form, b raised to the power of x, it's raised to something more fancy. We could also see something like this. H of x equals e to the x. And now e is not a variable. E is actually a number, known sometimes as the natural number, although it doesn't look very natural. It's called that because it shows up in nature way more than anything deserves to. It is approximately 2.71828, but like pi, which you're more familiar with, the decimal keeps on going and never starts repeating. Section 4.2 will focus on exponential functions using this as the base. So we're not going to look at that. We're going to focus on something like f. So let's look at it. f of x equals 2 to the x. And let's start evaluating a few points. f of negative 2. Ooh, that's one we might want to come back to. Same with f of negative 1. So I will come back to them. Actually, f of 0 even I will come back to. Let's start with f of 1. Well, f of 1, that would be 2 to the first. You raise anything to the first power, you get itself. So that's just 2. f of 2 would be 2 squared. Well, we can do that. 2 times 2 is 4. f of 3, then, would be 2 cubed. So 2 times 2 times 2 is 8. Now let's go back up. 2 to the 0. What does that mean? Well, you will recall from previous courses, you raise anything to the 0th power, and you get 1. There are reasons for that. Those show up in other videos. So I apologize. You can look that up elsewhere. How about 2 to the negative 1? What did a negative exponent mean? Basically, it meant that our base was on the wrong side of a fraction bar. So it's the same thing as saying 1 over 2 to the first, which would just be 1/2. So 2 to the negative 2, following that same argument, is 1 over 2 squared, or 1/4. And so let's notice a few properties that we see. The outputs that have shown up. These outputs here are all positive. Even when our x values started becoming negative, the outputs stayed positive. They just got smaller. And that will always be the case. So, the range of the function, and this will be true for any base, f of x equals b to the x, is 0 to infinity. Notice this is a non-transformed one. When we start transforming them, we can mess with the range. But if it's not transformed, that is our range. But I was able to plug in anything I want, so the domain is all real numbers. What we can see here is we keep getting more negative with our x values. We get smaller and smaller, but never quite reach 0. So we have a horizontal asymptote at y equals 0 along the x-axis. And so those are some general properties we will find for any non-transformed exponential function. So let's go ahead and graph this one. This will be a rough sketch. Let's see, we went through 0, 1. When we went on the negative side, things became fractional. But when we went on the positive, we went through 1, 2, 2, 4, and it'll be off my graph, but 3, 8, so somewhere up here. We get a function whose shape looks something like this, with a horizontal asymptote right there along the x-axis. Okay, so let's use that to graph g of x equals -2 to the x plus 1. And now notice, order of operations. This is a tricky thing for a lot of us. The order of operations is not necessarily tricky, but applying it here can be. I'll admit it throws me off sometimes. Making 2 negative in the order of operations counts as multiplication, which means it comes after the exponent. So what we really see here is we are taking 2, raising it to the x plus 1, and then making everything negative. This is different. It is not equal to -2 to the x plus 1. That would be something very different, and that actually would not be possible. It turns out when we have an exponential function, I need to put one more restriction on b. Well, 2 more restrictions. b has to be greater than 0. We need our base to be a positive number, or we're not going to have a good exponential function. Because notice I'm using all real numbers, which means 1/2 is a possible value of x. And what does it mean to raise 2 to the 1/2? That's the square root of 2. Well, if I'm using a negative number, that would be the square root of -2. That's an imaginary number, doesn't appear on our axes, so we're popping out of the real numbers there. But we'd be right back in the real numbers when we get 2 to the 1/3, which would be the cube root. Or sorry, -2 to the 1/3. So we run into an issue here. We do not want to see a negative base. We also don't want the base to be 1, because if the base was 1, 1 raised to any power is still 1. That's perfectly valid, but that's a simple horizontal line at y equals 1. It's boring, we're not going to deal with it. So we do have those 2 restrictions as well. Which means that negative and this plus 1 are both transformations, and let's see if we remember what they are. Negative out front. That was a vertical reflection. So we reflected the graph over the x-axis. And then a -1 on the inside, or sorry, +1 on the inside. +1, if we take x plus 1, that meant we were going left 1 unit. So we're going to take this graph here, do a vertical reflection over the x-axis, and then move everything left 1. Okay, so let's get some of my tick marks in. And let's use a different color this time. So we started with a point at 0, 1. Reflection over the x-axis puts it right down here. Left 1 would put it there. We had the point 1, 2. Reflect over the x-axis puts it here. Left 1 puts it here. We had the point negative 1, 1/2. Reflect over the x-axis puts it there. Left 1 puts it right there. We had the point 2, 4. 2, 1, 2, 3, 4. Reflect over the x-axis puts it down here. Left 1 puts it right there. And we get a graph that looks something like this. Oh, we've got a horizontal asymptote. We should also transform that. But it's along the x-axis, so a vertical reflection leaves it right where it is. Left 1, well, yes, we do move it left 1, but it's a line that's infinitely long, going left to right. So you move it left 1, you're not going to notice. And the asymptote is still where it is. So this graph now has a domain. Well, no transformations can change the domains. The domain of an exponential function is always negative infinity to infinity. However, its range could change. In this case, it did. The reflection over the x-axis meant I'm no longer going from 0 up to infinity. I'm now going from negative infinity up to 0. So we have a different range. One last thing I want to mention. Very short time left. We can solve some exponential equations at this point, and it's a method called relating bases. The simplest form will look something like this. 3 to the x equals 27. The goal with relating bases is we want to be able to write both sides as powers of the same base. Well, 27 is a power of 3 already, so I can rewrite 27 as 3 cubed. And now we just verify to ourselves that if I take 3 and cube it, I get 27. Well, 3 to the x equals 3 cubed. Let's look up above. Our exponential functions are 1 to 1. That means if we had the same input, we have the same output, that's a function. But if we have the same output, that's what 3 to the x and 27 are. Those are our outputs. If they are the same, then the inputs had to be the same. So that means x equals 3. Let's try one a little trickier. 8 over the 4th root of 2 to the x is equal to 1 over 4 to the x. Now here I notice everything is a power of 2. It doesn't look like it yet, but it will be in just a moment. Because 8 is really 2 cubed. We can rewrite a radical as a fraction, so this is 2 to the x over 4. And this is 1 over 2 squared to the x. So rewrite these and use our exponent rules. That's 2 to the 3 minus x over 4. And this is 1 over 2 to the 2x. So we have 2 to the 3 minus x over 4 equals 2 to the negative 2x. And there's your challenge problem. Finish that off. Hope this helped.